Okay, in this video we will specifically talk about the arithmetic sequence, which means we are adding the same thing every time. If it gets smaller, we don't think about subtracting the same thing every time. We think about adding a negative number. So it's all about addition. So the first thing we're going to do is we're going to write out the recursive formula. So the recursive formula, you have to define the first thing, the first term, which would be first term is equal to A. And then what are we doing to the first term? We're adding D to it every time. D is the common difference. So we can figure that out by subtracting, like the common difference here. This minus this is 2, this minus this is 2. So it's 2 is being added every time, and we can figure it out by subtracting 10 minus 8, 8 minus 6, etc. Then, once we tell the whole world what the first term is, then we do the previous term plus the common difference. So an is equal to the previous term, which is an minus 1, plus the common difference. The explicit formula allows you to jump anywhere in the sequence you want to go. So we do an is equal to, well, we need to know the first term, which is A, and then we're going to be adding a whole bunch of D's to it. Well, we don't add D the first time around, so we do this whole n minus 1 deal, because we don't add D to the first term to get the first term, we add D to the first term to get the second term. So you got to back the truck up and make it one less. So let's write out the recursive formula for this one right here. Well, that's a pretty easy one. Let's do this one down here. So what's happening every time is we are losing 1.5. So we're losing 1.5 every time. So we tell the whole world the first term, which would be 1, and we're losing 1.5. So we do an is equal to the previous term, an minus 1, plus negative 1.5. So we're adding the same amount every time. So the common difference is negative 1.5. So it's going down each time, but we're adding a negative number. Don't think about it subtracting, it's adding a negative number. Then the recursive or the explicit formula would be an is equal to the first term 1 plus n minus 1 times the common difference. The common difference is negative 1.5. And then we can distribute that through the parentheses and collect our like terms and stuff and simplify the formula. So an is equal to 1 plus negative 1.5n plus 1.5. So an would be equal to negative 1.5n plus 2.5. So that would be the simplified version, and there's just the straight putting it into the formula version. Okay, what are we going to do with this? Well, we can do things like find the 25th term. Now I don't want to just go subtract or add the negative number, all those times. I want to use the explicit formula. So an is equal to the first term, which is 26. We can see the common difference is 13, so it's going to be n minus 1 times negative 13. So if I want the 25th term, n is 25. So it's 26 is the first term, and then it's going to be 24, so 24 times negative 13. So negative 13 is being added 24 times to make the 25th term. So we start in the first term, we go to the 25th term, that's 24 steps. So it's 24 steps, that's where the n minus 1 comes into play. So let's put this into yield calculator. We get 26 plus 24 times negative 13 is negative 286. All right, so that would be the 25th term. Now we could sit there and just push the button over and over again. So we tell the calculator the first term, enter, and then we're adding negative 13, enter. So that's the second term, third, fourth, fifth, 6th, 7th, 8th, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 19, 20, 21, 22, 23, 24, and 25th term. See, I got the same answer. Boom, boom, same answer. Okay. Example 2, arithmetic mean. Basically, it's just an average. So we just do 92 plus 50 divided by 2, which would be 142 divided by 2, which would be 71. So it's 71. So 71 fits in here. That's the average between those numbers. Now, does that make sense? Well, it should make sense because I'm going up by 21. Excuse me. Then if I go up by 21 again, then I get to 92. So I'm going up by 21, up by 21. So how did I figure this out? Well, I just did the average. So it's a mean means average. So it's the arithmetic mean. Well, I can't really do that with this one. I have to find the second and third terms of this arithmetic sequence. So what I'm going to do is I'm going to go up by D, go up by D again, and go up by D again. So I'm going up by 3 Ds. So how do you go up by 3 Ds? Well, we start with 90, and we go up by 3D. So that would be algebraically 3D, and we end up with 12. So we're going to subtract the 90 over to solve this algebraically. We get 3D is equal to negative 78. Then we're going to divide by 3. That goes in there evenly. Goes in there 24 times. Is that correct? 26 times. My bad. 26 times. So it's negative 26. So I'm going down by 26 each time. So if I go down by 26, that would take me to 64. So to make sure this works, right? And then if I go down by 26 again, 38. And if I go down by 26 again, I hit 12. So those are the missing terms there because I'm going to have a common difference of negative 26. So how did I get that? Well, I did, I'm going down D, or I'm going, yeah, D, D, D. So it's 3 Ds. I'm just starting point's 90. I go down 3 Ds, and I end up with 12 is my final answer. So starting point, how many changes, ending up at 12. Solve that algebraically, I get negative 26. All right, there's the video for section 9.2, arithmetic sequences. And the 2 formulas that you need are A1 is A, AN is AN plus 1, or AN minus 1 plus D, and then the explicit formula is jumps you anywhere, so it's A plus N minus 1 D. All right, of course there's some conditions here. It says N is greater than 1 and N is greater than or equal to 1. So obviously this works for multiple things that are bigger than 1, or for N, like going up in the sequence.